Hello guys, welcome to the portal. I welcome you to the video of dehydrohalogenation, okay, which is our elimination type of reaction. So now here we have the opposite of hydrohalogenation. Remember, in hydrohalogenation we were adding HX to alkene, right, to form haloalkane. So but now we have haloalkane, we want to remove HX to go back to alkene, okay, so hence dehydrohalogenation. All right, here I have, here's my I and my H, okay, so I'm going to eliminate them. So here's my I, and then one of my H is here on water. Okay, I won't highlight all of them, but one of my H is there. All right, so now in this reaction, we are going to look at an interesting law that is almost similar to Markov-Nikov, but they are not the same, but then they are almost similar. So I'll look at that when we go to the next example. So now we have the reaction conditions. We have to heat our haloalkane. We have to heat our haloalkane, and then the sodium hydroxide or the potassium hydroxide, the one that we're going to use as a base, right? It must be strong base. As you can see, this is a strong base. Okay, these are strong bases. So I say we must dissolve it in pure ethanol, right? Instead of water, we dissolve it in what? In pure ethanol. So this makes it very concentrated. Okay, so now it must be very concentrated in order for the dehydrohalogenation to happen. Okay guys, so now if you can check here, the H that was eliminated is going to join the OH, right, to make water, and then the I is going to join the potassium cation to form potassium iodide. Okay, so let's go to the next example. Okay, let's go to the next example. Okay, so now if I have this, okay, here I have I, okay, here I have I, then this is H, 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 H. Okay, so what's the name of this molecule? You should know how to name these molecules by now. So so now if I add a concentrated solution of sodium hydroxide with some heat, okay, and then what product am I going to get? That's my question. Which hydrogen are we going to eliminate? I have a green one, I have the red one. Which one are we going to eliminate? The green one or the red one? which one. So now here we can have two products. Okay, we can have 1 2 3, okay, 4. If we eliminate the green one, then the double bond is going to be here. Okay, if we eliminate the green one, it means we will remove the I and the H, the green one. Okay, so now here we no longer have the H's because the green one has been removed. So now let's see what's going to happen. Okay, so now plus sodium iodide, okay, plus water. So plus water, our water is H bonded to an OH. Let's color it so that you don't forget which one is it. Okay, let's color it with a nice green. It's our green friend. Okay, so that's one product, that's one possibility of a product. So now we have another possibility of product. If the red one is eliminated, the red hydrogen is eliminated, what are we going to have? Okay, so if the red one is eliminated, the double bond is going to be here, right in the middle. Okay, okay, so now plus sodium iodide plus water. Okay, now this is our red hydrogen, okay, this is another type of product. So which one are we going to take? So we don't just decide things, okay, we use rules and laws. So there is a rule called the Zaitsev rule. Okay, the Zaitsev's rule. Zaitsev's rule. Okay, so what is Zaitsev saying? Zaitsev is saying that if we are performing an elimination, a dehydrohalogenation, the halogen, okay, not the halogen. When we are performing a dehydrohalogenation, the hydrogen that will be removed from the carbon that is the most substituted. Okay, so it's saying the major product is the one that H has been removed from the most substituted carbon. Substituted. Okay, substituted carbon. So now, what does this mean? It means that our double bond, it must be more substituted. It simply means that. So what you do is that we check our molecule, our haloalkane. So if I check this carbon and this one, so I have 1, 2, 3, 4. If I check carbon number 1 versus carbon number 3, which one is the most substituted? I can see that carbon number 3 is the most substituted because it is directly linked to carbon number 2 and carbon number 4, while carbon number 1 is only directly linked to carbon number 2. So I can see that carbon number 3, it is the most substituted. Okay. And what is Zaitsev saying? Zaitsev saying the major product is the one that H has been removed from the most substituted carbon. So it's saying that the most substituted carbon is this one, and the H that must be removed will be the red one. So meaning that the structure that is gonna be the major product or our main product is this one. Okay. So now this will be our major product, and then this one will be our minor product. You see. So now you can see that the one that we're going to prefer is this one. This will be our main product. Okay. And this one will be a byproduct. So that's all there is to with the Zaitsev's rule. It also applies in the in dehydration. Yes, in dehydration. It also applies in dehydration. Okay, guys, you can do other examples by yourself. Okay, now let's go to dehydration. Okay. So in dehydration, what are the conditions? Or what is dehydration? So dehydration is elimination of water from alcohol. Okay. So now, what are the conditions? The reaction conditions. So my conditions are I must use what? I must use a, a strong acid, right? And it must be in excess, a concentrated strong acid. So number one, I must have concentrated strong acid. Okay, so now such as our phosphoric acid or the sulfuric acid. Okay, so and it must be in excess. Remember, in hydration we have small amount of concentrated acid. Here it must be in excess. Okay, so another thing that we must have is heat. The heat must be quite high. In hydration we need only mild heat. So here in the hydration we need the heat to be quite high. Okay, so now let's get into it. So this heat must be high. Now if I have an alcohol, I have an OH here. if I have an OH carbon number 2, 1 2 3 4. Okay, so and then I say plus phosphoric acid, or they tell you concentrated phosphoric acid that is in excess. Okay, so it must be in excess. Okay, in excess. So now what what will your product be? And then the heat is high. I tell you it's high heat or high temperature or high temperature. Okay, or high temperature. So now what will your product be? Your product is going to be a ZF product, which is your major product. So it means now here we have two different hydrogens. We have this one. We also have this one. Okay, so now let's see. Let's start with the red one. So our product will be, okay, this will be our product. Plus what is dehydration? Okay, plus water. This alkene plus water, plus water. Okay, so now in this water our red hydrogen is there, somewhere there. So now what is another possibility? Another possibility is the green one. So I will have this alright, so I will have a double bond here. Okay, plus water, plus water. So now this is the green one. Okay, H. This is the red one. So now according to Zaitsev, Zaitsev's rule, so the hydrogen that will be removed will be the one on the most substituted carbon. So if I check, carbon number 3 is between carbon number 2 and carbon number 4. So carbon number 3 is the most substituted. So we will eliminate this hydrogen. Okay, so now meaning that this one is the major product. And then again our double bond is most substituted. So our double bond, it has one carbon, so it's between two carbons. Here it's only one side of the R group, so the other side is hydrogens only. So this one will be the minor product. So, and our main product is the major product. Okay, then our main product is the major product. Okay guys, that's all there is to it with dehydration. So we have done dehydrohalogenation and dehydration. So in our next video we're going to do substitution of haloalkanes with water and a strong base, and also substitution of alcohols with halogens. Okay guys, thank you. I hope you understand, and then if you don't understand, don't be shy to write on the comment section. Please like, share and subscribe. Okay, keep safe guys. Thank you.